Hi, welcome. We're super excited to have you guys here in another day for Snorkel's reading group. Today, we are very excited to hear about agents last exam, a new benchmark for evaluating AI agents on real-world, economically valuable professional workflows. So this work is led by Yiyou Sun and David from UC Berkeley's Center for Responsible and Decentralized Intelligence. The paper tests whether AI agents can complete long-horizon tasks in realistic computer environments with verifiable outcomes. The benchmark spans many professional domains from engineering and finance to healthcare, science, and creative work. Its core message is that despite strong performance on existing benchmarks, today's AI systems are still far away from reliably automating complex real-world works. Let's welcome Yiyou and David to hear more about it.
Thank you, Jason. I appreciate Snorkel can provide this great opportunity that allows us to share our recent exciting works. And as also, if you have any more questions, we can happy to connect after this presentation. Feel free to reach out to me if you have any question. So we call this agents last exam. I know that people know a lot of humanities last exam. We take this name, and I am a little bit regretful about this name. I think it's better name for that should be agents first exam. I will explain that later. So I feel like it's a first try to actually have a benchmark can measure the real workflow that's actually experts has done. But I think it's definitely not last. If I had another chance to work on this project, I would use the first exam. I mean, for now, just take it. So our one question, very simple, like can agents really do economically valuable works in the real world? We make it very testable at the level of professional workflows, not just the entire. Yeah. Today I will cover three things. So what the benchmark should measure and how to turn expert workflow to scalable, reliable evaluations, and what the current results do and do not show about agents' readiness. Okay, so this is a history of the benchmark. So benchmark is just not a benchmark. I mean, report score. As they do, if there's a verifiable, widely used evaluation, it gives a very clear signal to the whole field that, okay, when the systems can be compared, failures become very visible, and iterations can speed up. So these curves in the past years shows that patterns, math, coding, and reasoning, they show that why benchmark design matters because we optimize what we can measure. So now the question is whether agent benchmark can actually now measure the work we actually want agents to do. So, okay, the Anthropic chief states AI will surpass almost all humans and almost everything shortly after 2027. But I guess the progress is not, there isn't very good concrete measure for that. So whether or not if we trust this timeline, the expectation has shifted. Like agents are increasingly discussed as a system for the professional works, not just question answering or mathematical reasoning. That raised the evaluation bar. So we really want the benchmark that actually has complete software-mediated workflows and the quality of the resulting artifacts. Okay. So this chart shows a coverage mismatch. So agent benchmark recently concentrate on computers, mathematical domains, which only represent 7% of all the US job market. So the remaining 93% is not an automation estimate. So much of that work is more about physical or outside agent scope. So this, the narrow gap is still very large, like many software-mediated workflows are in management, finance, law, or engineering, they remain underexplored. So this is how benchmark can lead the process of the whole field. So it's a common loop here. So when you have a very well-defined benchmark score and the people in these frontier labs will follow and they curate training data, something like that to get the points, right? And also they will diagnose on where the agents makes right or wrong. and to improve the score. And they announced the model, say, hey, we are state of art. So the thing is not about like people hate benchmark score nowadays. It's just something, okay, you have such a score, but I feel like ops 4.7 is such a shit. I mean, people hear about this on Twitter, right? So the important thing is isn't benchmark the bad thing, it's how we can actually measure the things in the right way. So if we have a benchmark, imagine that they really reflect our real work workflows. I don't mind if it's got saturated, right? So if this such a benchmark can be saturated, it means that they can really help me do some real work. So that's the philosophy, yeah. So what should an agent benchmark measure? So to answer that coverage question, we start with the external map of the work, the 2018 US Standard Occupational Classification with 867 detailed occupations across the economy. So the next step is to use this to identify what's the computer-centered workflows within that map. For example, of course, there's lots of jobs like Uber driver. Of course, you cannot measure that with agents, right? So we need to filter out those subsets with computer use. So we made some study. Okay, we filter out those computer-centered work and cluster the workflow and plus some of the frontier fields because the world map is still date back to 2018. So we add 2 frontier fields. It's more on the AI side. So in total, we have this diagram. If people knows our website, you can click on a 1-minute video. You can see a great animation we produced with that diagram. So in total, we defined this 55 fields. This is supposed to be a nice video, but for some reason, it's just single standard static slide. But I hope people can have just rough sense of what we cover. But we have that on our website. Cool. So I will use a single example in this actual industry. So this is the real manufacturing workflow that we discussed with lots of experts in China. In China, you know that manufacture takes 70 or 80% of GDP. So manufacturing is such a large area, but there's no benchmark mentioned about that. So we incorporate this part, and we actually discuss with a company or factory in China. They give us data, they give us environments, and we summarize the 3 most important workflows that constitute the whole chain in that manufacturer. So I'm just giving an example here. So this company actually produced some iPhone shell. So to start with the iPhone shell, you have the structural engineer. You start with a 2D print design, and you have the structural engineer convert to a 3D print, something like this. And when you have a 3D blueprint, you need to, because the final goal is to produce an iPhone shell, right? You need to simulate the temperature when you actually produce this iPhone shell, because we all know how a plastic shell is formed. Like you start with some plastic and you melt it with a high temperature and you put it into to be the machine and to shape it. So you need to simulate, okay, where is like fragile and where is like the concerning part, and that's called a mode flow. You use a very specialized software to do the simulation. And then after you do this, you need to figure out how you cut off. You start like a cube. You cut that into piece by piece. Like you make sure the cut path does not collision. So that's that's kind of most representative workflow here. I just give one example. If one day, okay, the agent can really automate these pipelines, you know, the whole industry is really get powered. But so far, these tasks are in the last Gazan tiers in our benchmarks, and so far there's no agents can have the score higher than 10% of that, and the pass rate stays 0. Okay, so what makes AI different? So firstly, the scope. So we have like more than 300 experts on board, like they contribute actually the daily task. And then we also contains in total 1,500 tasks across 555 fields. And also, that's something I want to share with people more about. People are actually equalized CUA, which is computer use agents, equals to GUI agents. But in my opinion, computer use agents is a more broader concept. It should include both the CLI and the GUI operation. So in order to differentiate these two concepts, so we call it generalist computer use agents. I think this term has starting to be adopted by many papers. For example, recently Seed 2.1 Pro technical reports use this term called generalist computer use agents. And also there are people also calling computer use 2.0. Yeah, that's another term. So, but people are starting to realize the combination of GUI and CLI will be a new trend of this. Okay, so the third, I would say the third part is our tasks in our benchmarks are largely verifiable. But verifiable, I'm a person that don't like the LLM's judge that much. I'm not sure if people here are the same, because if you ask questions that's very subjective, like LLM's judge is very, unreliable, have low agreement with that. So if possible, we are using the deterministic code verifier to verify the outcome. So, so putting together these ingredients that makes our benchmark different. First, like if we map the existing benchmark scope to our scopes, you can see we cover like 55 subdomains, while the SweetBench or OS words only cover 5. And if we have MMLU here, it's around here. So I would like to say we have one of the most coverage benchmark so far. And also I think we are the first benchmarks that consider GUI and CLI together. So the philosophy says that I just give you the environment and I give you input. I don't care about how you achieve the goal, whatever the GUI operation you made, whatever the CLI you take. Like as long as you can finish the outcome, I don't care about that at all. So actually, we have very interesting findings that in many Linux tasks, you don't need for people. Okay, for the biology, just like you need to see a brain image, you need rely on a software like a 3D viewer to see the brain image layer by layer. But the agent does not need that at all. They just skip their software and do what they want, and they can still pass the task, which is totally fine. So I think there are people from companies like the Minimax see that the problem is they say, okay, we really love this benchmark. Why? Because the combination of the GUI and XCI and how to balance it is exactly the next wave of the models they are looking at, and how you train a trajectory with a good balance of that. So I think people are starting to notice the importance of that. So I want to highlight that we are the first benchmark that has a, of course, our benchmark is hard, and we also produce the hardest tier that only have the best agent reach 2% of pass rate. And okay, I think people care about most is that how do we create this benchmark? So the hard part is just not collecting the prompt. It's just translating the professional intent into a benchmark interface that do not lose the authentication, authenticity, and the evaluatability. So ALE starts with the actual work that experts have done in their daily lives. Okay, so this is the actual blueprint we collect from a Chinese factory. So I don't know what this item it is, but we collect the inputs and we collect outputs. And I asked them, okay, if you have an intern, how do you judge the quality of the work has been done? So they tell us a little bit, and I translate into the language that our computer can verify and understand. That's a large workload on our side, and but actually we guarantee that it's authentic jobs that work. People, you should be assured that these are all the real work. There's no synthetic task at all in our benchmark. So should be a video, but unfortunately I cannot play here because it's a static site. So when we ask experts about the task, we define three most important criteria. So first, it should be representative. For example, people may submit tasks like, okay, implement this 2D print, convert it to the 3D models using the AutoCAD. But that's the software that is, of course, AutoCAD produced the 3D functionality, but they never use that in reality. They actually are shifting now to Rhino or other software. So actually, we need to define that as something that actually people are doing, so that we call the representativeness. And another thing, the second thing is complexity. We don't collect workflow that only need one or two single clicks. For example, apply color filtering on an image. It just need a few clicks, and we reject workflow like that. We want a whole end-to-end workflow. For example, luckily here we have this example showing. So it's put a cheetah on the runway. So it's an end-to-end workflow. It needs lots of combination of the process in between to actually convert to have this outcome. And also, of course, most important case is verifiable. A few days ago, there's an article makes me upset. It says, okay, ALE as a benchmark focusing too much on the verifiability. So they will lose a lot of the reliability, which I don't agree with that at all. Because in my opinion, non-verifiable task can also be converted to a verifiable task. That can be in two different ways. The first way, you can change the prompt in a way you design a task to be verifiable. To give you an example, giving you the prompt, okay, build an RPG game to me. This is so people can build a tons of possibility of RPG game. I know lots of benchmark using human judge and compare to game, okay, or Elms judge to compare to game's quality. And yes, it's effectively, but finally, if we want to scale it up, even using the RL training, you need it to be automatic, right? So in that case, we can change the prompt in a way that, okay, reproduce this Flash game in exact game map, in exactly game status. So people know that a Flash game, people cannot use Flash to program things like a 2016 or something. Yes, this is a very realistic task that you need to reproduce this game in that way. Wait. Not on Apple? Okay. Okay. I see. Yeah, it's a real need. I just say. So if you convert your task in a way that you ask you to reproduce the game, and our final verifier is to compare the screen or the game state one by one, then you make the task actually verifiable. So we focus, yeah, that's one thing. Okay. So when we give the expert instruction, we define these 5 components. And expert submission, they need to combine these 5 things. The task, the input files, what tools you used, and the expected deliverables, and the final, the evaluation criteria. So engineers will make this package executable by wrapping it to the final task. And so all the submission pipeline, and we are still accepting new submissions on our website. So feel free to check it out. So this is a living benchmark. Like we will, to prevent people from contamination, we actually will change our batch every 6 months. So there's no way you can okay, if you if you overfit our benchmark too much, that's not good, because in our new batch, you will still have the low score. So it's a rolling benchmark. We are still accepting new submissions. So when people submit on our system, it will immediately get the review. It's just like a paper submission system. Strong accept, borderline accept. In order not to frustrate them too much, I changed the minor reject to the minor revision, and change the reject to the major revision, so people feel good about that. I still have a chance to be adopted. So this, we made a paper submission system like that, so they will immediately get the feedback like that to keep the quality of the task is high. Okay, this is a full pipeline of how we build a task. As I said, we start from the package, input, output, software, criteria, instruction. And they submit online, and on the website, they will immediately get this AI review. But AI review, you know, sometimes I don't trust that much. But it's a first gate to filter out these low quality submissions. So after that, our engineer will take over of task and start to implement it. Of course, we will spot numerous problems in between. And this the internal email channel, and we send tons of the emails in March or April to communicate with them with the potential problems. And yeah, and when found issues, we will send email back, ask the expert to. And finally, we will have the QC committee control and from like a peer review from other experts to make sure a final task is actually valid and they're actually the real work. So people may be curious about the submission, how the quality of the submissions. Actually, this is the final statistics. The initial submission comes out as this part, largely this part. Actually, based on our feedback, we largely move this part to this part. So the review system is really helpful to keep the quality of the tasks. So unfortunately, there are still large portion of the tasks which stay minor revision or major revision. And I don't know, maybe I just discard it, so I will once implement it forever. But we prioritize implement and sharing the high quality tasks on the top. Yeah, please.
Can you talk a little bit more about the source of where get those
Experts, yeah.
Like expert, it's a subjective word that can be more specific on what kind of like industry people.
Yes. The combination of both industry people and researchers in other fields. So we, as you said, we start with 55 subfields, and we reach out people, and we send lots of posts early in March and April, and focusing on, okay, we are hiring experts in this specific field, and please come to submit, and you will get authorship. So people, I can share a little bit more fun story about that. When people think, some people, people's attitude towards AI are very diverse. Some people say, okay, if I'm helping AI, no, I want to collaborate with you because I'm afraid AI will take over my job. But some other people, they want to embrace the AI. So people actually, these are the people we want to work with. So they also want to know more about AI to participate in this process. So that's an incentive for them to, even though I don't give them money, so they still want to participate in this procedure. Yeah.
You have the overall profile. Sorry. Oh, great. Do you have the profile of the expertise, say their education level, year of experience, which industry they are working on, which industry they are working on?
It's a tricky part. So if you want the institution, I think we have all the information shared on the appendix in the archive. You can see where it comes from. But to share their expertise level, it's about some personal. Some people may from some very confidential industry. They don't want even to know where he works at. So we just put them as an individual contributor. But they actually from some very real industry. Yeah. Okay, can you pass the box to?
Yes. Oh, sorry.
You said that some people want nothing to do with AI. Where do you get the least amount of support with external collaboration? You said that some people, they don't want to support it if they know that it's working, that's going to support AI. So curious, where do you get the least representation for expert opinion, expert input?
Are you asking if the people don't want to support AI, well, they reflect the quality of the?
Like where are the non-uniformities in your distribution?
Well, they impact the influence. I don't think so. I think kind of people is still a few, but there are some people who had very extreme attitude. Okay, I don't want to work at all. But this kind of people only like less than 10%, I would say. Yeah, most of people are like nice people. So, yeah.
Yeah, just to follow up on that topic, because people are aware that the success of this benchmark could enable AI to take over a significant amount of industry work, especially like as you mentioned in this presentation, computer-aided design like AutoCAD and Rhino, and people who are doing image augmentation, like for example, Photoshop experts. What kind of social kind of like impact do you like are you able to talk about or diffuse if there are potential like kickbacks?
So you're asking that if our benchmark will endanger their job?
Or have you had people who have opposed it, like
yes,
openly voiced it?
definitely have some people opposed to that, and of course they will not collaborate with us. But I think it's open question. Everyone has different answer. I just post my answer. I feel in the future, did code take over our job because as an engineer? Not yet, right? It just helped us. I think we need to build an ecosystem that human is on the designing side and agent focus on execution side. So we are designer and we don't want tedious job, but the agent can take over that. But let me give you a very concrete example. So if I'm going to build a website, if I'm a website expert, I know, okay, I will prompt agents. Okay, you need to deploy the front end in the Vercel, you need to deploy the database in Neon, and you deploy the backend in the cloud. So you still need this professional knowledge to make your website still robust. But if you just begin on website, you just ask them, okay, build a website for me. It's just like a very low quality. So that's what I want to say. The expertise still be needed even with the AI. So people know about this industry also know how to better use AI. So I think that embracing the AI is the right attitude for these people. Like, yeah.
So what you're saying is that you're targeting the segment of the population who are working in professions where they would like some AI assistance on the side, and right now
Yeah.
trained in that particular line of work, so they can help train the AI to the point of being like assistant to help support them in their work in ways like coding is right now, but for other professions they're not able to support those professions in the same way.
Yeah, as you can see, like most of the tasks we collected are more about execution side. So as you said, if the task is about designing, it's also hard to measure. So here, if we want to make the task verifiable, it's important, it's just about execution. The output is verifiable. Yeah.
Can I ask really?
Yeah. Yeah.
So I really like your 6-step agent harness that you've built, and it's really nice for evaluating a task on kind of an open Claude equivalent where you've minimized the tool calling and stuff to make it quicker. But why do you want to separate measuring? Like, I feel like the harness and model is like a pair that shouldn't be broken up.
Oh, yeah.
And we should measure those things like this harness plus that model or that harness plus that model as a separate thing instead of using your harness.
I did not use my harness.
Oh.
If you check our benchmark, we list 3 columns: harness, model, thinking effects. So you can use whatever harness combination of models you want. Please. Yeah. Yeah, no problem. Well, I think we can. Okay, so this is our current distribution. I cannot guarantee the distribution is the final distribution of the real world. I just want to do some broader coverage, and if we can approximate more, that's good. So far because we have a very strong cooperator from manufacturer side, so we have lots of the collaboration here. This information are all in our papers, and I just here for illustration. So that's the early question a discussion I put on. The real work function require both the visual and the programming access. To complete tasks that you need not just the GUI operation, GUI interface. You can also use like a CLI interface, but here I just for illustration. But this you can treat as a CLI interface to complete the workflows, whatever way is acceptable. Okay, so this is in discussion. Okay, this is another discussion topic I want to discuss with people here. people say, okay, in the future, GUI operation. So how many people think that the GUI will die in 5 years? The GUI interface will be useless to agents in 5 years. But there's a large group of people who think that, yeah, you think that GUI will, yeah. So there are definitely a lot of people think that GUI will be fully replaced by CLI. But I want to share my opinion. So let's consider a very extreme example. So if you ask agent to play a game, the game company released the internal API for you? No, right? Because if you know the internal API for that game operation, it's like you're hacking the game. So that's just extreme example. But consider there are some software companies, they don't want, the agent can take over them, yeah. Even though I feel they want to gain some advantage, they can still expose a few CLI or API interfaces, but it's incomplete. For I can tell, because when creating this benchmark, I studied so many softwares. They like in the Blender or even the model full of software I just shown. They provide API, but it's a subset of the GUI operation you can do. And also there are some companies, they have some internal softwares. If you want a generalist agent, you cannot fully rely on CLI. And also people don't trust GUI. It's just simply because GUI is so slow compared to CLI for now. It's like 50 times slower. But imagine, so in my opinion, GUI operation, the speed or the quality does not need to match the CLI. It just needs to improve a little bit. For example, if it's only 5 times slower than CLI, it can cover lots of the fields already. So that's why I still hold positive to the GUI operations, and in the future they can still be, it's valuable. So that's my opinion, but I'm happy to discuss with people here and to hear your thoughts. It's still open questions. And also, there's no ground truth answer. Yeah. Cool. So here we want to make it general. So our benchmark, as I said, I defined a generalist computers agent similar to a human body. I want to make sure, okay, the agent that we are testing is a full human. It has a brain. It has the eye, which is the GUI perception. It's not anyway. So you have the orchestration layer. Some pure GUI agent that people tested like 1 year ago, it's purely a single loop of a GUI click. Screenshot, click. I mean, they don't have the orchestration layer. So I want to make sure the agent test, we have the body part. And we also have the hands, which is tool API coding. And also you have the full runtime, like a VMs, Docker, shares. So, and as you see some earlier agent, like a CLI agent, suite agents, they don't have the GUI perception. And some GUI agents, the support of orchestration and the tools are runtime also limited. So we want to tag the full like a OpenCloud the earlier version of OpenCloud doesn't have the GUI as well, but we give them the GUI harness or the API to make sure he is not blind. Yeah. Okay, so here is every task with this controlling this one controlled lifecycle. So you start with load task inspection, and the agents do the loop, and when you have the output, you send back and evaluate and give you a score from 0 to 1. And of course, we will keep the reference in a safe place so that when agent is executing the workspace, it's impossible for you to get access to that to prevent from leakage. So at high level, like how we verify the outcome. So there's a majority, there are 2 ways. First, by default, okay, we measure based on the final deliverable. Okay, I will give one example is that, for example, if your output is a video, so we will have prescript action. So we find that, okay, the 10 clips at a certain time stamp, we extract the frame and compare with the reference to see if it makes sense. And if it is a game, you take some actions. Okay, you do the up, right, and you take a screenshot of the game to see if it's exactly the same with the game state of the reference game. That's of course, if there is just numeric values, it's easy to compare as well. So this is a high-level design. Of course, okay, there's another way, so we can measure in between the intermediate milestones. This is, we ask LLMs to, when you reach certain milestones, you report what you have done, and we evaluate based on that. That's a high-level design of how we measure the progress. Let me use two examples here. So for example, this is a flash, this is a, which one is yeah, this is the original Flash game. This is a game that's reproduced by agents using the RPG Maker XP. It's quite similar, right? With only a few bugs that, for example, if the people are flashing to the position without opening the door, but so they're losing some scores. So that's one example. So here is a G-code deterministic, how we verify that. We have the tool path here, and then it can be written in a document. We check that if they have collision, and check if the final products match the reference outputs. There's many ways to build this evaluator. So actually, so now I'm going to produce some results. So today's agents can still do the real works. So we have this last exam here. You can, so the shaded bar is about the scores, the fine-grained scores, but the solid bar is about the final pass rate. Like if you finally passed all the checks, you get a score 1, otherwise 0. So Fable 1's score is low because people know that Fable is such a weird model when we're testing. So it rejects you like it's about safety issue. I don't want you to work on it. Like I need to rerun it again and again to make sure it's to pass the security gates. And also it will secretly downgraded to ops 4.5. So you just take this score for fun. I mean, don't take it serious. So, but all I want to say that the last 8 years, the pass rate is still very slow, very low. And here's the overall score in the GPT-5.5 with the X high efforts, and the Claude Code is still leading ALE. But of course, that people may heard about the new models is coming from some companies. I can tell it's very strong. Just don't leak it. Yeah. We internally test their model. It's quite strong. Yeah. Okay. Okay. So that's the self-reported score of Fable 5. So it's like on the agentic coding, it's like it's top of all the benchmark. But why in our case the Fable 5 is not still similar to GPT 5.5? We are also very surprised when we see these results. The reason is complicated, but I will explain to you one by one. So a single agent does not win everywhere. For example, if you see the Fable 5 in life science and the visual and media, the performance is far behind the GPT 5.5 and Composer 2.5. Of course, one of the reasons is that it secretly downgraded performance. It has some weird restrictions. And also, I just want to say, okay, people are looking at the coding benchmark too much, and the coverage is a little bit skewed nowadays. If we focus on all spectrum, actually models are perform surprisingly similar. And also, I will give some examples of where the model performs differently. For example, this example is where Fable 5 pass, like create a post. I don't know about this, but someone here can help me understand. But I just read it. Like create a poster, IMRT plan in a mat ready and export a consistent DICOM plus QA. Yeah. So Fable 5 passed it, but Composer 2.5 and GPT 5.5 failed. And then this is another example, like a revealed chest array in micro DICOM, and a Fable 5 and GPT 5.5 passed, while the Composer failed, but still get some scores. So there's another example, which is actually Composer 2.5 is doing good job, but the GPT 5.5 and the Fable 5 failed. So like query the preloaded circulate database in Metabase and export the 11 required metric. So they all are good in some different perspective. Also, this is the slides. I think Fable 5 is gone, but I think it's interesting to share still. Like Fable 5 falls back in 1 in 3 rounds. In total, we have 152 tests, like 51 switched to the Ops 4.5 secretly. And that's the areas they have most severe fallback. For example, life science, health and medicine, neuroscience, social science. Actually, I talked with people in Anthropic. They say yeah, it's expected. Cool. So and also, that's a comparison of if we use the same model but different harness. So well, they perform same or similar, but I would say harness largely impact how you use the tools. So you can see we have the batch, file, GUI operation, web, planning, other. So even the same model, GPT-5.5 uses different harness. They have different patterns in using the tools. And also here's a comparison or discussion, like a model is more important or harness is more important. From our test, my answer is that if you harness have a basic structure, similar to OpenClaw, you can simplify it, but don't lose too many tools or the oxygen. Like just at a reasonable harness, performance are actually similar. So, but the models can really change a lot. For example, if we fix the harness OpenClaw and you just change the model, you have like 18 scores variant in variations. But if you just fix the model, but you change the harness to Codex, AI Claude, like Cursor. Oh, I want to introduce AI Claude a little bit. So that's our self-implemented structure. We want to prove whether there exists minimal harness can have a similar performance to the like a very popular commercial harness like OpenClaw or Claude Code. Actually, we largely reduce lots of unnecessary system prompt or tools. We found that the performance are surprisingly similar. So I'm not saying harness is not important. I just, from my observation, you just have the necessary part. You can, yeah, maybe that's sufficient. So that's observation. Also, I want to highlight that Claude Code is too expensive. It's way too expensive. So we have if people are following our bench leaderboard on website, we recently run Claude Code Max. It's having the best score so far, but it cost about $4,000 to test 150. I always receive the complaints from my professor, like you are draining my labs. So yeah, so actually, I'm just saying that people not should just focus on the performance, but also let's care about the cost as well. Yeah, also different harness will really also change the performance with even with similar performance, but you can control the cost with harness as well. If you have a very well-defined harness, you can achieve similar performance, but with like 41% of lower cost. Okay, as a final summarization, okay, we also provide us AI CLI, so which we don't need a GUI at all, but we just focus on Linux task. And I know that people are using the terminal bench nowadays, but we just say, okay, we have an AI CLI subset, which has much lower pass rate, which means a higher complexity, and also has longer horizon, because averagely, if you want to complete terminal bench, you just need 5 minutes. But in our benchmark, it average takes 15 minutes. So, and also we have much larger domain coverage. So I just saying, if you want to test the terminal, you can consider using our AI CLI, which is also easy to use. You just need a Docker. Yeah. And also going back to the first, so why we call it last exam. So last as a competence threshold, like if you pass the exam, it really means that agents can do the real job for you. And also it's difficult as a difficult frontiers. So it really sits at the boundary of what today's agent can do. So it's final, this is a QR code on a different source like website, GitHub, data. We're all open sourced of this 150. And also thanks for reasoning. I know that people have lots of questions, and I'm happy to take it one by one.
I guess this relates to my previous question. Like, do you have any like quantitative evidence is they saying this is a good benchmark.
Mhm.
And a relevant question is like, if you look at the subfield with compare with the cross-check with the existing benchmark and look at the ranks of the models, not the top models, but the middle one, like how consistent the ranking that come from your benchmark is aligned with others, right? Not the top three because I know they are the top, but more like in the middle.
So here, it's this guy cost us $4,000. Also, this guy cost us 500. Okay. Composer 2 point. This is cheapest. Try it if you have some easy work. Try Composer. Yeah.
I mean, like, I guess my question is how is this rank consistent with other common benchmarks?
I think if you see the current trend is largely follows, right? This is the top two tiers, top two model, and the others follows like Quen DeepSeek, are a second tier. So the Composer is also, I think it basically aligned with people's expectation. Yeah.
Then why this is a so-called benchmark if the like is this more about the absolute number, the pass rate? If the rank is
I think it's consistent in the tier 1 and tier 2, but inside each tier, they have different performance. For example, they are performed differently in different domains. If they want to optimize on that domain, for example, as I said, Fable5, maybe ops as performs that well on life science, but GPT-5.5 is better on the visual and the media. I mean, it gives it's not just a single number. The single number is averaged across all domains, but it gives a signal of where you need to optimize at. So that's what I say in benchmark, just not just a number. And also, I also sent them the trajectories we have. So when these companies like Kimi and they asked me to provide more about the trajectory, I did send them because it's a very important signal to diagnose where their models run, and they can compare with the best agent to improve their model. Yes. Yeah.
Hi. Thank you for the talk. Just pretty amazing. That I read a lot of paper related to the last exam. Just one question. Did you track the process of agents taking that exam and trying to find out where does it fail, where's the experiences of the agent are taking the exam, and all the thinking process? Is the exam like a binary pass or fail criteria, or it can be more like nuanced, more in detail? Tell us like the process of the agent like taking this.
Oh, so your question like where agents fails, and then can we have more insights about that?
Will there be a like evaluation method to help us see the process and also evaluate that process?
Oh, is our evaluation taking consider of how you do this? Yeah. So my answer is yes and no. So we mainly measure only based on the outcome, but sometimes if there's only one necessary pass, of course, and it's hard to. Also, we want some fine-grained score. We also ask them to have an internal reported milestone, and we measure that internal milestone as well. So, for example, as a data statistics task, you need to download some target, files, and we definitely check if the files are internal downloaded. If it's success, we give you some credits. So we definitely have some of the internal checkpoints, but only if it's some necessary points. So otherwise, we don't measure. Okay, if you use GRE, I give more credits. If you use CLI, I give more. I don't do that because in whatever you achieve the goal is acceptable. Yeah.
Curious if you examined like a LoRa where you train the model against the harness, so the model learns the harness first before you run that harness model pair. And if anyone's done this before, if you've heard of this, and then maybe like some models are like they're fine tuning that designs that LoRa that then you inference off of within your agent loop becomes much more efficient and much more capable for certain model harness pairs. Like the LoRa possibilities might be better on certain models than others.
So the question is, if you have some specialized models, heavily trained on specific domains.
So like fine tuning of a model usually generates like a LoRa. So like, for example, like let's say you run a typical model harness pair against a task and it didn't pass the test, but you run it 1,000 times and it passed it 50 out of 1,000 times. So you can actually train a LoRa that is a file that you give to the model as at inference time. And then maybe you go from 50 to 500 now after it uses that LoRa.
Oh, you mean, can we train based on task to improve performance?
With the harness. So like teaching the model that it's being used by this current harness system.
Yeah, definitely. If you want to overfit on that, you can definitely train on that with our verifiable to get higher score. But you need to consider that if the performance can generalize to other tasks. Yeah.
Yeah. Okay.
Yeah. Not sure if. Yeah.
I'm curious if you can go to that game slide and like explain how is verification happening there.
Oh, cool.
To the agent produced game. Yeah, this one. Yeah.
Yeah, this one. So we give the VM judge a very specific question to ask if the game map exactly match with the reference. And if the game status, for example, the health, attack, and all the coin and experience exactly same with the reference image. So I don't avoid asking, we use LLM as judge, but I need to make sure our question asked are very explicit and unambiguous. So for example, I will also ask if this subcoin or sunny coin appear in the image. So this is to prevent that, okay, you just submit a same reference image to us. And if this coin appear here, it means that you are actually using this software to reproduce that. So we have several very explicit asks to the VLM and each question will get some scores. Yeah.
There's like two concerns there. One is, so for the reference game, this might, let's say, just be, one particular, level or one particular random instance.
Yeah, yeah.
How are we expecting an agent to exactly come up with that level or that instance?
Oh, because we gave the game executable file to the input. So we asked them to reproduce that game exactly using a new engine, new game engine.
Well, you gave like the executable itself to the...
Yeah, this is part of input. Like I gave you the Flash game. Okay. And you just need to reproduce it with a new game engine, which RPG Maker with that.
Then this second issue was, are you only looking at the, the visual output or also the gameplay itself? Like what's the action and then what's the observation and like that sequence?
No, so on this task, we only compare, okay, we have agent to self-reported the internal, when they finish the game design of single level, they just take the screenshot and then write a report. And then we compare with that self-reported milestone and with the reference. Yeah.
Hi. So I'll start with like a reasonable assumption, which is that like in a few months, it's probably very likely that like agents are going to become really good at like this benchmark, right? So given that the time that it takes to make a task that's like actually really hard for like a state-of-the-art LLM has been going up, I wanted to ask you if you think that it's like a good use of like time and resources for like the research community to keep trying to make benchmarks that are like harder and harder. So for example, making like a ALE2 as opposed to like working like other things, so for example, like self-improving architectures and stuff like that. So like what's the trade-off of like when should we stop just trying to like make things that are like harder for the LLMs?
I think the hard is a good thing because for now, people need harder tasks to complete their daily tasks. But in the future, the hard is not the only pursuit because I only care if they can complete our daily works reliably. For example, I will use the history of math. We give you an example. I think for now, people are not chasing for harder math problems because math can already solve the IMO level problem. I would say it's already much smarter than most of us on math problems as agents, right? So on the math problems, people are less presuming for harder math problems, as long as they can solve like 95% of problems. I think it's the same for other areas as well. So as long as you can solve the 95% of daily tasks, I don't think people will focus on harder problems. It's just why we presume hard at this stage because they're not there yet.
I see. So do you think that like after you get to a point where like the LLMs are good at like doing like most of like the actual like useful, they have like economic impact tasks, it's like almost like worthless to spend time making like harder benchmarks? Would you say that?
Yeah, I mean, at that stage, but ALV, are you asking about plan of ALV2?
Sorry?
Are you asking what's the plan of ALEV2 and what's the task?
Yeah, I was just asking I agree that it's really reasonable to keep making benchmarks on things that are useful for the society, as long as LLMs are not good at that, you know. But I'm asking do you think that after you get to a point where LLMs are really good at basically doing all of those, do you think that there is even a point in us still trying to make benchmarks that are pushing different here?
I mean, of course, in subdomains, you still need benchmarks to measure the progress and how good in that subdomain. For example, in math problems, they still have benchmark called frontier math, to track the most. I mean, if that age is coming, as Dario said, 2027, probably we need the benchmark in all subdomains to have very, very clear study in that domains and to push the frontier of that. But for now, I think it's more about people are still competing for the generalist agent, right? So I think a generate, have wide coverage is still the current scope. So that's why I'm saying the benchmark, it's really a roadmap of what the current agent needs. So at next year may be different. Next year may be different. For example, 1 year ago or 2 years ago, the most important benchmark is MMLU, is just QA, right? Because agent most role we will expect it to answer the question correctly. So it needs to meet the current need of of people from agents. I think
just one question. Do you deal with tasks that have one more correct solution? For example,
would you mind be closer to the box?
Okay. How do you deal with tasks that have more than one correct solution? For example, CNC tool movement. Optimal movement is NP problem. So there are many ways to achieve the same task. Do you allow in tests multiply correct solutions or only single one?
You're asking if there are some multiple trajectories to complete the same task and
as I'm encoding, you can solve for the same problem by multiply ways.
Yeah, of course. I only care about outcome, and we only define the rubric based on outcome. If you can achieve you can pass that check written by our experts, you can. Oh, if the task has multiple correct solution. Okay, yeah, so the answer has a different format. In some of the task is deterministic. For example, reproduce the game is a deterministic. But in some other task, for example, you give a parameter of the simulation. So the experts will give as a range. If you fall into that range, it's acceptable. Yeah, I'm not sure if I answered that question.
Oh, there's a range for different errors, but what if tasks have several completely different solutions? That is, my example is tool movement.
To move,
you can cut the same shape by multiply ways.
Yes, that's a good question. So we check so if you're asking a G-code problem, you produce a tool path, right? So you can cut in different way as long as they don't collide into each other. So it's a valid tool path. And also if the output is with that cut and you can produce output that matches our reference, it's also acceptable. And in some other numerical tasks that they are definitely multiple correct answer, we will have a pool of correct answer. And if you fall into that range, they are all acceptable. Yeah, that's a good question.
So we'll have one more question before we break out into a social group. So yeah, who's gonna take it?
I have a question. So, yeah, we can take more in the social section, but I will take the.
Yeah. So you mentioned that I think the text creation. I'm a bit confused, but either the text creation or maybe the benchmark evaluation is verifiable. Which part is verifiable and how do you verify it?
So you're asking if our task is verifiable?
Yeah.
Which part make you?
I think, did you mention that, the text creation part is verifiable or
No, just the output and the criteria. How we measure the success of the task is verifiable. it's not because people are familiar with GDP eval or the remote work index. It's rely on the human expert as judge. So to me, it's not verifiable from the, yeah.
How is it like verified?
So in our task, that we only collect tasks that's, as the example I showed, you can compare with the reference and you can validate with a verifier, with a code, with a deterministic code. Yeah.
So most of the texts are like deterministic?
Yeah. Most of them have a short acceptance range and are deterministic. We purposely curate tasks like that. Yeah. Cool. And I'm happy to discuss more in the social section. Yeah.